right, today we are almost to the end of consumer arithmetic. It's been almost 2 weeks, I think, we're at this topic. After today's topic, simple interest, we'll be moving on to compound interest, and that will wrap up our series for now on the consumer arithmetic. So today our focus is simple interest. In yesterday's video, if you didn't get a chance to look at it, we could go back and look at how we did wages, how we dealt with wages and salary. And earlier in the week, we look at things as unit costs and also, what's the other one? I can't remember. But you can check it out. And on that note, of course, you can subscribe so that you can always get the latest video as I post from Mondays to Fridays for now. Good. So what are we going to do today? Today we are going to understand, first of all, the concept of simple interest, not just how to work it out. Naturally, we know to work it out sometimes once you know the formula. But today we're going to look at understanding what is simple interest really all about. And of course, we're going to look at the simple interest formula, and we're going to wrap it up by looking at a problem involving simple interest. Well, problems. I think we have two in this video. So off the bat, what is simple interest? Basically, it is a means or a system where the positive sum of money can either be increased or decreased over a given period of time. And this is just generic definition. The thing I think we need to understand primarily about simple interest is that the sum of money that is either increased or decreased is dependent on the basic sum that we deposited. And that's where the whole idea of simple interest surrounds. So in other words, if I put on $100, let's look at it like that. Every deduction or addition, because remember, an interest could increase or decrease your sum of money accordingly and exponentially, depending, right? So if I put $100, the thing with simple interest is that it doesn't matter how much years the interest rate is affected, it always goes back to the base $100. That's one thing you need to understand. And that is basically the essence of simple interest. So I go to the credit union, and let us say they add 7% interest to my amount of money. Let's say that's what happens at the credit union. And they operate using a simple interest. In that case, all you're saying is that based on the sum that you're starting with, your amount of money will increase 7% over a period of time based on your initial amount. In the next video, when you see we look at compound interest, you'll notice that there is one major difference. In the compound interest, and allow me to jump the gun here, the sum of money calculated each year is not necessarily the starting amount. It's the starting amount compounded with the interest for that given year. Thus, your yearly capital or principal, we could still use principal, will be different. And that is just the concept. Simple interest is applied in many different institutions. Banks, some banks use them, I must say, but banks mostly use compound interest because it benefits them more too. But you have some banks, you have credit unions, you have saving companies and institutions, or whatever the case may be. Yes, they use simple interest, and oftentimes it is used to increase your sum of money. So that is one of the things that they use as incentive for you to consider them to be one of your, let's say, financial institution, because yes, they tend to increase your money over a period of time. Of course, we have the on and off cases of decreasing, but maybe we could discuss that at a different time. Or in your business classes, you could question these things in business classes, yes, because the decrease of an interest is quite interesting. And that is something we don't hear a lot or be taught a lot, but let's leave that there. Or you could ask in the comment section and we could have that discussion. Right, so let's go into the formula. The formula is as simple as this. So simple interest is equal to the principal multiplied by time multiplied by rate divided by 100. It's a very easy formula to remember. I remember learning this in Form 3. Yeah, and I never forgot that. It was a really simple formula. And the simple interest, of course, will simply mean that that's the interest that you will be receiving. So the interest, some put is simple interest, some put interest, and sometimes we might see SI, simple interest, SI. And let's go in maths, of course, you'll see it abbreviated like this. Also here we have the SI again. So simple interest, or the amount of interest you receive, is equal to the PRT over 100. Knowing the formula is one thing, very important and very easy to learn. But more important than knowing the formula is knowing what is principal, time, and rate. Interest speaks for itself. That's the amount that you get whenever you do whatever. Good? Or whenever your money goes through whatever process of time with whatever rate given. But let's understand what each term means just so that we could move forward even smoother. So first of all, the principal is the starting amount. So the amount you're depositing, the amount you want to invest, the amount you want to start up with, call it what you may. The starting amount is always known as your principal. In some accounting books or some business classes, you might also hear this amount or this sum called the capital sometimes. But I won't call it the capital because the capital has a different concept altogether too. But sometimes it's referred to as a capital, is your starting amount, but not always. So I prefer to stick to principal. Principal, not principal. Right. The time is the period in the terms of years. So the time is the period in terms of your years in which you want your sum of money to be what? Increase, decrease, well, you don't make plans to decrease. But in which the interest will be affected. And I emphasize here, your time is a period of years. Time in this formula must be represented as years. In some question, sometimes they give the time as months. And when that happens, you need to convert your months into years. And that's very simple, very simple. So supposing I give you a question and your interest is for 3 months. Whatever CMDM you work out and you want to have an interest for 3 months, to use simple interest, you cannot put 3 months. You have to convert the months into years. And the easiest way to do that is by dividing that 3 into 12, and you could break down that into 1/4, and then you could break down that into a decimal and all if you have to. If you want to put that as a decimal and write it down just the same, that's okay. That would be as a decimal 0.25. But this time here must be in terms of years and not months. So if you get 3 months and then you put 3 here, your answer is wrong already. Tell you that already. What you calculate there would be, well, let me not say your answer is wrong, but what you calculate here at the end of the day will be your interest after 3 years and not 3 months. If you want to put 3 months, then you have to put 0.25 or 1/4 or 3/12. Again, if you get 3/12, I suggest that you break it down, right? So please bear that in mind. That's very important, and that is the number one area where students tend to make mistakes. They know to identify the capital, the principal, they know to identify the rate, and for the time, we oftentimes ignore whether it was given in months or years. If it's given in years, then you're good to go. Just put whatever they give you. But if they give you in months, that's the only thing that you have to be conscious and make sure that you convert the months into years. Represent it in terms of years, and you're good to go. And last but not least, of course, we have the rate, and the rate is the percentage in which your money will be either increase or decrease. Good? But for now, of course, we'll be focusing mostly on increase. In the world of economics, you have to go both ways, but I just letting you know it could. But for maths, we more so look at the increase part of it, to be honest with you. All right, so let's go. That draws the end of that concept. Let's see if we could do a 2 example here now. So $10,000 is invested at 8% per annum for 5 years. What is the simple interest payable? Well, easy doesn't. So we want to know how much interest you will get after you deposit or after you invest, in this case, $10,000 at 8% rate. So this is the rate, 8% at 5 years. Notice they gave us the years in years, so there's no need to convert. And simple interest is as simple as just applying that. So the interest, or SI, let's keep it that way, simple interest is equal to PRT. It doesn't matter the order in which you put it, because it's multiplication. Earlier I would have done multiplication in algebra. I explained that multiplication is commutative, so it doesn't matter the order, you will get the same thing. 3 times 4 is the same thing as 4 times 3. The order doesn't matter. And this here will be the same as, now my interest here would be 10,000. So after 5 years, it will be 10,000 times the rate, which is 8, times the time, which is 5. And in this case, it's okay to put 5 because remember, the 5 is given as years. And all that will be divided by 100. Yep, and this does it. So let me take out my calculator here. So I have 10,000 multiplied by 8 multiplied by 5, and all that's divided by 100. and I get here 4,000. That's 4,000. So after 5 years of investing $10,000 at 8% rate per annum, after 5 years, you would get $4,000. And that answers part A. And again, remember to state your answer. State your answer. So what is the simple interest payable? The simple interest payable is $4,000 after 5 years. And in the part B now, they ask us to find the amount accruing for the investment. And you could see the amount accruing as simple. There's a formula for that actually. So the amount accruing, AC, or sometimes I just put A, is equal to the principal plus your interest. That is your amount accruing. So it's basically the amount you started with plus the amount of interest. I like to call that the total sum of money you get after the interest period. Because remember, the interest, as I said earlier, is amount of money either added or increased or decreased from your sum of money. In this case, it is added because you are investing. So here it will simply be 10 grand. So it will be 10,000 plus 4,000. Good. And when we add that sum of money, our amount accruing will be 14,000. Yeah? Yeah, and that is it. That answers part B there. So how much money after saving, sorry, that's part B there. So after, well, look at a B. Let me do that over. Right, so yes, after saving for 5 years with a 8% rate at $10,000 initial amount, you would end up getting $14,000. So you could see that $14, for example, like this. If you go in the bank, okay, let me use this reference. Let me say you open a fixed account. A fixed account is an account in which you have a sum of money, but you cannot take away. You cannot take from it. You just have to leave it there and let the interest do its thing. And let's say you put $10,000 there. After 5 years, if you're operating with a simple interest at 8% rate, after 5 years, you would no longer have $10,000. Instead, you would have now $14,000. And that's a beauty. And that's one of the things that encourages people to save and one of the things that promotes interest. When you know that you could put a lesser amount of money, for want of a better word, and end up getting more money for that, with technically doing nothing but waiting time, that is why people do savings, that's why people invest, and that's why people go into interest or dig into interest. One of the things you might hear about, and maybe the students, you may not get it, you might be young still, but the adults that might be listening to this, you will know that in the future, when you're looking for a saving institution, a bank, or some financial place where you want to do business, one of the things we tend to generally go for is the place that has the best interest rates. And as it is today, that is one of the reasons why a lot of the unions, credit unions that is, are growing fastly, because they tend to mostly have better rates than the financial institutions such as the banks, which might seemingly be the go-to for a lot of people, or at least back in the days. And here we have a final question, and this one incorporates a little algebra, and I choose this one purposefully because you need to understand that not all the time they will be asking you to calculate the interest. Just like any other question, once they give you whatever information, is you to identify the unknown. So I could ask you to find the principal if needs be, the rate if needs be, or maybe sometimes the number of years, and you need to be able to do questions like this. So in this one, they ask us to find the principal that will earn $200 simple interest in 8 years at 6% annually. So here now we're finding the principal. So let's find out what we're given. So we have SI. We know what is the SI, the simple interest, according to the question. And I'm only doing it this way because you have to be able to identify what is given. This is $200. And a matter of fact, I should have done that in part, the first question too. Identify what was given before we apply it, but that's okay. So here we're given the simple interest, 8 years, so we know the time. And the time here is given in years, so there is no changing to do here. So the time is 8 years. And we were also given the rate, so we were given R. So the rate here is 6%. Yes, we know that. They give us the rate at 6%. So what they ask us to find here? The principal. We don't know what is P. And we just have to do a little algebra here. I hope you did not forget how to do your algebra. We did a whole series on algebra, subject of the formula. Maybe I might attach it to this just to refresh your memory, or you could just look back for it, search for Everything Mathematics, or if you subscribe, you will already know how to find the other videos. Right, so let's find P now. Of course, finding P doesn't change the formula, it's the same formula, but we just have to do a little adjustment. So SI is equal to PRT over 100. And I will make P now the subject of the formula. And to do that, I cross multiply my 100. Allow me to put I instead of SI. That's okay, don't worry, it's the same thing. So I 100. I ain't explaining the steps here. Just go back at those videos and we will know how to do it. So I 100 is equal to PRT. I just cross multiply the 100. And now I want to get rid of the RT, which is bounded by multiplication. And according to the rule, to get rid of multiplication, we divide. So I'll do 2 in 1 time because it's the same sign that I divide in both. So whatever I do on one side, I also do on the other side. So I have RT here. So RT cancels RT here. So that will now leave me now with the principal is equal to I 100. And this is why you need to understand how to make the subject of the formula, people. I remember when I was in school, we literally had to learn. I can still remember that. We had to learn the formula for principal, we had to learn the formula for rate, and we had to learn the formula for time. In the event that we had to find out the principal, the rate, or the time. But look at how much easier it is now when you know to find the subject of the formula. You don't have to go and memorize P is equal to I 100 or, well, I mean, you could if you want, but I ain't giving you that and I would not go through that. I will give you the initial formula and you need to be able to play up with the formula. Play with the formula, make it the subject. With the main formula, you could find R, you could find T, you could find P. And that's what I just did here. Of course, if you want to go and learn it individually, you could too, but I think that's wasting time and maybe brain cells too, and you could have been putting in something else there. For all I know, I don't know. Right, allow me to erase this here because I need some space and I cannot go to the next slide. Right, so that's just the information that we have above here, so it doesn't take away anything. Right, so now that we have that, I just substitute my values, right? So I know P is still unknown. I know that the interest, I is interest, the I was 200. So I just substitute in values. The 100 remain 100. That's what was in the bracket. And below now, the rate was 6%. So that is rate. And I'm multiplying that by time, which is 8 years. Easy does it. So let's take a calculator here to simplify our life. So 200 times 100, although I don't need a calculator for that, you could see that 20,000 already, but again, laziness. Right, so that's 20,000. 20,000 divided by 6 fours are what? 48? Not 48. Yeah, 48. 48. I'll just confirm. Divided by 48. And that gives us our golden answer of, I do need a calculator for this one to calculate it faster. 20,000 divided by 26, sorry, by 48. That gives me $416. I was expecting this answer to work out cleaner than that, but it is what it is. $416.67. And I round that 67 cents to the nearest cent. Let me just put 2dp for faster abbreviation, which is the same thing, right? So yeah, so that's what we have there. $416.67. So this was our principal. This was our starting amount, if you want to call it like that. And when we save $215 for 8 years at what, 6% rate, we end up making $200 interest on that. And one of the things that is nice to do, I mean, if I would do it if I have time, but this video is already gone too long, 19 minutes counting. One of the things you could do, you could just put this into the initial formula. So use it as your principal here with the given rate and the given time, and you would see that you would end up with 200. Well, more than likely you'll end up with something close to 200 because for this I approximated, and as you know, well, not as you know, maybe you don't know, but once you start approximating your answer, you are going away from the real answer or the true answer. So you may not get exactly 200, but you will get something very close to 200 because I round off the decimal places here, right? So yes, this will bring us to the end of Simple Interest. As always, again, like, share, subscribe, and stay tuned for the next and final video on the consumer arithmetics when we do some compound interest. Until then, see you and take care. Enjoy your weekend.